Top 10 tractors that changed farming forever. They weren't built for show, and they weren't made for speed. But over the past century, 10 tractors have reshaped how America grows its food, works its land, and defines progress. Some were born in wartime, others came from handshake deals that quietly redrew the global blueprint for farm equipment. One was so large, so specialized, it was never intended to be replicated. This isn't just a ranking of machines by horsepower. It's the story of mechanical systems that outlasted the factories that produced them, machines that pulled through dust bowls, labor shortages, and $5 diesel. These are the 10 tractors that didn't just help farmers, they changed farming itself. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, case IH Quadtrac 715, torque, tracks, and tomorrow. No detail was simplified, no regulation left unmet. Released in 2025 under Tier 5 emission compliance, the case IH Quadtrac 715 wasn't a refinement. It was a structural reset. Beneath its composite hood sits a 16-liter FPT Cursor 16 engine, twin turbocharged and intercooled, delivering 715 horsepower with continuous torque stability under extended load conditions. Its continuously variable transmission was calibrated for high-resistance terrain. At the same time, the independent 4-track layout delivered not just traction, but reduced soil compaction by up to 30% compared to conventional wheel-based tractors in the same class. This wasn't an update to an older platform. It was a direct response to a threefold pressure: increasingly strict emission laws, measurable soil degradation in commercial farmland, and persistent labor shortages across the US and Europe. Inside the cab, the operator environment was rebuilt from the circuit board up. Suspended cabins, modular joystick clusters, and the AFS Pro 1200 terminal fully integrated with third-party ecosystems. Compatibility with Raven, FieldView, and Ag Leader systems gave mid to large-scale farms unprecedented real-time data fusion, a level of interoperability rarely offered in high-horsepower tractors. Marketed at a base MSRP of $800,000, the 715 targeted large acreage operations in North America and Eastern Europe. But its actual impact had little to do with volume. It became the first ultra-high horsepower tractor to meet EPA Tier 4 final, California CARB, and EU Stage 5 emission standards, all without requiring aftermarket adjustments. Independent engineering assessments from Asabi and the German DLG Institute confirmed an average 11.4% improvement in fuel efficiency over its predecessor, the Quadtrac 620, under standardized field conditions. Strategically, the 715 accelerated land consolidation by allowing fewer operators to manage exponentially more acreage per cycle. Its compatibility with semi-autonomous systems made it ideal for high-intensity tasks like dryland seeding and spring tillage. It didn't just replace older tractors, it reframed the labor model that modern agriculture runs on. As of Q2 2025, the case IH Quadtrac 715 is operational across over 3.4 million acres of cultivated land globally. No recalls, no emissions violations, no pending litigation related to drivetrain or regulatory failure. Its mechanical record is auditable, its compliance status is clean, its influence is still scaling. This is not the machinery of tomorrow, it's already in rotation. Ranked 9th. Allis Chalmers. D-Series, the diesel line that bridged two Americas. There was no press release to mark the shift, no ceremony to signal the pivot. But between 1957 and 1969, Allis Chalmers quietly introduced a series of tractors that reoriented the expectations of both the American farmer and the machines they trusted. The D-Series was not conceived as a flagship. It was a solution, a modular, adaptable, no-excuses line designed to fill the void between wartime durability and modern specialization. The range began with the D14 and culminated in the D21, the latter becoming the first row crop tractor in the U.S. to surpass 100 rated PTO horsepower, a psychological and mechanical milestone that reshaped industry benchmarks. Where earlier tractors relied on gasoline or LP gas for fuel, The D-Series leaned hard into diesel, capitalizing on rising fuel efficiency demands and engine longevity expectations that were beginning to define the 1960s post-war farming economy. The design wasn't luxurious, but it was industrially honest. Planetary final drives, power director two-range clutches, and live power takeoff were engineered not for brochures, but for fields, for heat, for grit, and 16-hour shifts in high-resistance soil. The D17, in particular, became a mainstay in the Midwest. Its ability to switch between fuel types, its affordability, and its integrated hydraulics made it a rare trifecta for farms balancing grain, hay, and livestock. Dealership networks across the Rust Belt documented a new demographic curve during the D-Series era, a spike in owner-operators under 40. It was the first line from Allis Chalmers that didn't intimidate the small grower, and the last to do so before the brand's eventual absorption into AGEO. From 1957 to 1969, over 250,000 D-Series tractors were manufactured, and even now restoration parts remain actively traded among legacy equipment owners and vintage tractor associations. Unlike the experimental or luxury machines that followed in later decades, the D-Series was designed by the land. It either performed under pressure or it didn't survive the season. And by that metric, output, uptime, and mechanical reliability, it passed repeatedly for over a decade. The Allis Chalmers D-Series never sought recognition, but it became a bridge, from gas to diesel, from manual to semi-live hydraulics, from the mechanical memory of war to the data-driven agriculture we recognize today. Ranked 8th, Massey Ferguson, 35, the tractor that tilled the developing world. No treaty dictated its spread, no central agency coordinated its arrival. But from southern India to rural Ghana and across vast plateaus of Anatolia in northern Argentina, the Massey Ferguson 35 became the most recognizable agricultural machine outside North America or Western Europe. Not because it was the most powerful, not because it was the most advanced, but because it worked in all directions, with all fuel qualities, under all hands. Launched in 1957 following the Standard Motor Company acquisition, the MF-35 was built on a platform of technical restraint and functional pragmatism. Its 37 horsepower Perkins diesel engine offered a modest torque range, but unmatched resilience. It tolerated irregular fuel quality, accepted field-side repairs, and remained operational after conditions that would sideline more delicate machines. In the Northern Hemisphere, it was a tool of small acre productivity. In the global South, it became something else entirely. Infrastructure. British development banks, Australian agricultural programs, and Canadian export agencies issued thousands of MF-35s throughout the 1960s and 1970s as part of bilateral aid agreements and mechanization grants. In Uganda, over 800 MF-35s were delivered between 1964 and 1969 under a Commonwealth-backed rural modernization initiative. In Pakistan's Punjab region, smallholder plots under 5 hectares gained primary mechanization access almost exclusively through MF-35 imports via international lending. The machine's simplicity enabled vertical training. One driver could teach 10 more. Mechanics trained on it could work on anything else. Spares were locally reproducible. Fuel tolerances could be adjusted manually. And because the MF-35 avoided most post-war over-engineering trends, it operated in places without paved roads, service networks, or guaranteed electricity, and kept going. Its adoption rate outpaced local infrastructure itself. In several regions of sub-Saharan Africa, MF-35 tractors were used not only to cultivate, but to haul medical supplies, construction material, even people, tasks never envisioned in its design brief. Still, they made it possible by an architecture that privileged mechanical access over technical complexity. Over 500,000 units were produced globally. Licensed versions and rebranded knockoffs appeared under various national trademarks well into the 1990s. Today, operational units remain in service across every continent except Antarctica, including documented original builds still in daily use. The MF-35 was not a symbol. It was a chassis that moved food, labor, and memory across fault lines of economic transition. Its legacy is not in museum glass or collector circuits. It's on the odometers of working machines that outlived the agencies that deployed them. Ranked 7th, Ford N Series, the machine that democratized mechanization. It wasn't built for legacy. It wasn't engineered to impress. The Ford N Series was engineered to solve a national shortfall. Too many acres, too few hands, and no scalable machinery that average farmers could afford. Between 1939 and 1952, 3 models under the N Series designation, the 9N, 2N, and 8N, restructured American agriculture from the bottom up, not through horsepower or innovation in isolation, but through pricing, production scale, and a bold departure from the elitism of pre-war machinery design. The N Series was born from a handshake between 2 men whose names would define separate chapters of tractor history: Henry Ford and Harry Ferguson. Ford brought manufacturing scale. Ferguson got the revolutionary 3-point hitch system. That agreement, never fully honored in court, but sealed in hardware, produced a machine that offered hydraulic implement control, reduced operator effort, and eliminated the need for complex linkages or manual coupling chains. The 9N debuted in 1939 with a price tag under $600. Nearly 40% cheaper than its closest industrial equivalent. That wasn't incidental. It was a direct strategy to put tractors into the hands of America's smallest landowners, just as the country prepared for wartime production and labor loss. Its 4-cylinder gasoline engine was simple, accessible, and built with wartime metal constraints in mind. The rear wheels could be flipped for adjustable width. The lighting system, when installed, ran off a 6-volt battery that could be repaired in any rural shop. During World War II, the 2N emerged with steel wheels and magneto ignition, re-engineered to minimize the use of restricted materials like rubber and copper. It became the literal and symbolic engine of food security for domestic production, with over 300,000 units deployed during the conflict. But it was the 8N, launched in 1947, that rewrote the national average. Painted red and gray, equipped with a 4-speed transmission and upgraded hydraulics, the 8N became the single best-selling individual tractor model in U.S. history. Over 530,000 units by the end of its run in 1952. For the first time, mechanized farming wasn't an elite or commercial endeavor. It was a standard. The legacy of the N Series isn't housed in innovation labs or technical journals. It's in the county ledgers of post-war America. The rapid mechanization of over 2 million farms between 1940 and 1955. It's in the Farm Security Administration photographs of tenant families using factory-built tractors instead of draft teams. It's in the shape of every modern 3-point hitch, which still bears Ferguson's triangular logic and Ford's scaled compromise. Mechanically, the N Series is no longer in service. Economically, its blueprint still governs how machines reach the field. Ranked 6th, Allis Chalmers WC, the tractor that rolled on air. No other tractor from the 1930s altered industrial expectations quite like the WC, not by brute strength, not by design complexity, but by answering a material problem with a manufacturing solution, and then scaling that answer across American farmland faster than any tractor had before. Released in 1934, the Allis Chalmers WC was not the first tractor of its type, nor the most powerful in its class, but it was the first to arrive fully equipped with pneumatic rubber tires as standard, a decision that turned a risky engineering gamble into a national mechanical default. At a time when steel-lugged wheels were still carving ruts into prairie topsoil, Allis Chalmers introduced air. Rubber tires changed field behavior overnight. Where steel wheels had sheared wet soil and amplified slippage, pneumatic tires improved traction, preserved topsoil integrity, and extended working hours across moisture gradients. Fuel efficiency climbed, operator fatigue dropped, and repair crews could service tire damage in a fraction of the time it took to replace a fractured steel cleat. By 1936, over 95% of WC orders were fulfilled with factory-mounted rubber. Not optional, not experimental, but assumed. The manufacturing response was equally radical. The WC was the first row crop tractor to be mass-produced using assembly line methods, mimicking, but not duplicating, the automotive strategies pioneered by Ford. With modular component sub-assemblies, paint line automation, and on-site casting, the West Allis plant delivered more than 170,000 WC units between 1934 and 1948, making it the company's most produced tractor model during the pre-war and wartime years. Technically, the WC featured a 201 cubic inch four-cylinder engine, crank-started and carbureted for low-octane fuel. Its power takeoff shaft was belt-driven, typical of the era, but field reports noted early innovations in live hydraulics integration that would be fully realized in successor models. And while Allis Chalmers never claimed the WC as a top-speed machine, its top gear offered 11 miles per hour, quick enough to cut travel times between fields that, in earlier decades, could eat hours off the workday. During World War II, the WC's design remained essentially unchanged, but production shifted to emphasize repairability and logistics compatibility. Field units were retrofitted with tow adapters, allowing them to function as light-duty transport vehicles in war-adjacent agricultural zones, particularly in the western U.S., where wartime labor constraints disrupted planting and harvest cycles. The WC was phased out after the war in favor of the more advanced WD line, but its architectural DNA, pneumatic traction, modular production, and scalable design remained embedded in Allis Chalmers' engineering strategy well into the 1950s. Today, the WC is not remembered as a symbol of elegance or engineering supremacy. It is remembered as the point where American farming stopped resisting industrialization and began embracing it with mass production, operator comfort, and an understanding that steel alone wasn't the future. Ranked fifth, Farmall H/M. The platform that unified the American field. It wasn't the largest tractor on the farm, nor the fastest, nor the most powerful, but between 1939 and 1954, more American fields were touched by Farmall H/M tractors than any other mechanical platform of the era. Not because of any single innovation, but because of an architectural principle. One machine, many functions. The letter series Farmalls were international harvesters' answer to a specific question. How do you create a row crop tractor that can switch roles without switching hardware? The H&M were built on that answer. At 24 and 36 horsepower, respectively, they sat at the core of the mid-century family farm. Too large to ignore, too essential to replace. What separated the H&M from their competitors wasn't brute strength, but compatibility. Each was designed with a central powertrain that could support dozens of attachments without modification to the chassis. Planters, cultivators, mowers, and belt-driven machinery could be swapped in minutes. No machining, no rebalancing, just mechanical fit every time. The engineering language of the platform reflected this intent. The power takeoff shaft was standardized across implements. The rear lift arms were vertically stabilized, not side-mounted, making them more forgiving for uneven terrain. The tricycle-style front axle gave the H&M the ability to maneuver tightly spaced crops with surgical precision, even by today's standards. And because the machines shared a common component pool, maintenance was reduced to a parts shelf and a toolkit. By the mid-1940s, Farmall H&M tractors had become the mechanical default for mixed crop farms in the Corn Belt. International Harvesters dealer networks supported them with field kits, hydraulic retrofits, and operator training programs that would later be copied, but never quite matched, by competing brands. Mechanically, the M pushed the envelope further. Its four-cylinder engine could be upgraded to the Super M, which increased compression and torque output without altering the transmission housing. This modular expansion path meant farmers could scale without replacing the tractor, a rare economic advantage during post-war material rationing. Between them, the H&M models accounted for over 550,000 units sold. Their longevity was not the result of marketing, but of field logic. By design, they asked less of the farmer, fewer compromises, fewer downtime hours, fewer decisions about what tool to leave behind. Everything fit, everything worked. Today, restored Farmall H&M tractors continue to operate on hobby farms, historical demonstration fields, and in some cases, low-acreage working plots. But their primary contribution is not preservation, it's precedent. The modern notion of a tractor as a universal field platform, not just a puller or power source, begins here. Ranked fourth, John Deere Model A, the sound that built a brand. No machine in John Deere's history made more noise, not in decibels but in recognition. The Model A didn't just move soil, it moved perception of the company, of what a row crop tractor should be, of what American agriculture was becoming. First introduced in 1934 and placed into full production in 1938, the Model A was Deere's answer to the Farmall Regular. But it did not copy the format. Instead, it offered its solution to visibility, stability, and multi-row adaptability. It arrived with a vertical grille, flared fenders, and a sound no other tractor had. The two-cylinder Johnny Popper engine, low RPM, horizontal, and unmistakably mechanical. The Model A wasn't just a vehicle, it was Deere's first mass-market statement, a declaration of design independence. Its engine configuration, unlike the inline fours of its competitors, created a rhythmic exhaust tone that farmers could hear from across the field. An auditory brand marker decades before sonic branding became a marketing term. That sound became identity. But the Model A was more than acoustics. It was the first John Deere row crop tractor with adjustable rear wheel spacing, enabling farmers to customize track width to their field geometry. Its hand clutch was positioned to allow fast transitions between tasks without engine disengagement. And with live PTO introduced in the later variants, it stepped beyond traction and into full field functionality. Deere didn't just build the tractor, it built the image. The Model A marked the introduction of Deere's now iconic green and yellow color scheme as a consistent production feature. Before the Model A, color in farm equipment was arbitrary. After the Model A, it was tribal. From 1934 through 1952, Deere produced over 300,000 Model A units, a figure surpassed only by its successors. But the significance of the A series isn't in volume, it's in alignment. The model represented a convergence of engine architecture, color, sound, and function. For the first time, John Deere's machines didn't just operate differently, they looked different, they sounded different, and they were remembered differently. The Model A is no longer in active use, except in collector fields and vintage demonstrations. But its engineering DNA, horizontal engine lines, stylized intake profiles, and operator visibility principles, persists in Deere's design language to this day. It didn't just define a machine, it represented a manufacturer. Ranked third, John Deere 4020, the benchmark that refused to move. It didn't arrive with a slogan, it didn't launch with a new logo. But when the John Deere 4020 entered production in 1963, it set a mechanical benchmark that its competitors would chase for over a decade, and that some users still haven't left behind. The 4020 wasn't a prototype or a statement piece. It was a refinement platform, the second-generation follow-up to the 4010, incorporating the feedback of farmers, mechanics, and internal Deere engineers across all major performance categories. Power, stability, hydraulics, operator interface. Every measurable dimension was updated, not reinvented. Its 6.6-liter diesel engine delivered 91 PTO horsepower, placing it in the upper range of row crop capability without tipping into overbuilt territory. At full load, it produced torque at 2,100 RPM, ideal for grain augers, forage harvesters, and field cultivators. But raw output wasn't the reason it became a mainstay. It was the total system response. The 4020 featured closed-center hydraulics, a pressurized circuit that delivered fluid only when demanded, improving implement response time while reducing parasitic drag. The differential lock, a feature rare in its class at the time, gave operators traction redundancy on uneven or loose surfaces. Its SoundGuard cab, though optional in early models, eventually became an industry standard in later variants, reducing cabin decibel levels by over 50% and transforming long-hour operability from endurance to routine. Adoption was immediate and sustained. Between 1963 and 1972, over 184,000 units were sold, the highest figure for any Deere model in that power class. More importantly, aftermarket support remained consistent. The The 4020 was mechanically accessible without being crude, field serviceable without compromising complexity. Tractor technician training manuals from state ag universities in the 1970s routinely featured the 4020 as a core reference machine, not because it was universal, but because it was stable. Unlike earlier row crop tractors that had to be adapted for implements, the 4020 was built with them in mind. Its three-point hitch could handle heavier rear-mounted loads without compromising frame balance. Front-end loaders, grain drills, rotary mowers, each could be fitted without frame extensions or hydraulic remapping. Today, restored 4020s retain market value far beyond their expected depreciation. Verified units in working condition routinely trade above $25,000, and auction houses list them as both functional assets and collectible hardware. That economic persistence reflects a basic fact. No tractor before or since has occupied the middle space between price, power, and reliability with the same mechanical precision. The 4020 wasn't designed to be iconic. It was intended to be exact. And for tens of thousands of American farmers, it still is. Ranked second, Ferguson TE20, the geometry that redrew global agriculture. It measured just over 10 feet long. It weighed less than 2,500 pounds. But the Ferguson TE20 carried a geometry that forced every other manufacturer on Earth to reconsider the connection between machine and soil. Introduced in 1946, the TE20 wasn't revolutionary because of its power, rated at just 20.3 horsepower. It was revolutionary because it reorganized mechanical responsibility. Before the TE20, tractors pulled. They implement their weight. Linkages were passive. The Ferguson system changed that dynamic with a three-point hitch that actively integrated implement force with tractor balance, using downward pressure from the implement to improve rear-wheel traction. It was not merely a new hitch. It was a dynamic control architecture. At the core of the TE20 system was draft control. By measuring resistance from the soil through the lower links, the hydraulic system could automatically adjust depth without input from the operator. This allowed for consistent plowing depth across uneven terrain, reduced slippage, and lowered fuel consumption, all without electronic sensors or software. It was mechanical logic at its most elegant, but the TE20's legacy wasn't limited to design. It was scale. The tractor was built under license not just in Coventry, England, but in France as the FF30, in the United States as the TO20/TU30, in Australia, and indirectly inspired entire national tractor programs across Eastern Europe and the Global South. By the mid-1950s, it had become one of the most widely produced agricultural machines in the world, with over 500,000 units manufactured before the line was folded into the Massey-Harris merger that created Massey Ferguson. What made the TE20 scalable wasn't its engine or chassis, it was standardization. Its mounting points, linkage dimensions, and implement compatibility became so ubiquitous that entire generations of farm tools, plows, cultivators, drills were built to Ferguson geometry, even by companies that never built the tractor itself. This licensing model, in which local manufacturers adopted the architecture while building around it, made the TE20 the most copied tractor of the mid-20th century. Its mechanical DNA exists today not just in Massey Ferguson, but in Mahindra, Ursus, and countless regional models that emerged in post-colonial agricultural systems. The Ferguson TE20 no longer dominates auction blocks or dealer lots, but its system does. Every three-point hitch used today, every implement designed to pivot through soil rather than right above it, and every hydraulic draft response that doesn't require electronics, all trace back to this modest silver gray machine. The TE20 didn't change farming by being everywhere. It changed farming by making its logic inescapable. In first place, Big Bud 16 V747, the apex load engineered by hand. No part was off the shelf, no component borrowed. The Big Bud 16 V747 wasn't manufactured. It was assembled to specification at full scale for a field that required more torque than anything commercially available could offer. Commissioned in 1977 by the Rossi brothers of Havre, Montana, and constructed by Northern Manufacturing Company in Havre, the 16 V747 remains, by all available records, the largest agricultural tractor ever built. It was not a production model, it was a request answered. The engine is a Detroit diesel 16V92T, a 16-cylinder, two-stroke power unit originally designed for mining and industrial haulage, not tillage. At peak configuration, it produces 1,100 gross horsepower and 1,900 pound-feet of torque. The power flows through a twin-disc 8-speed transmission into custom Clark planetary final drives, engineered to tolerate consistent pull at triple the load pressure of standard four-wheel tractors. The frame is a one-off steel monobeam chassis with integrated flex points for lateral articulation. The tires, 8 feet tall and 3.5 feet wide, were custom-built by United Tire Company, Goodyear, and later Titan, requiring dual bead support and inflation pressures regulated manually in each quadrant to prevent rutting under deep pull conditions. Fully ballasted, the machine weighs approximately 135,000 pounds. Its primary purpose, pull a 14-meter, 80-foot-wide cultivator through hard clay subsoil at low speed and full depth. This is not a tractor for general-purpose farming. It is not designed for maneuverability, transport, or operator comfort. It is built to do one job, pull more than any other wheeled agricultural vehicle has pulled, continuously across hundreds of acres per day. Unlike smaller machines, the 16 V747 does not scale to the user. It requires pre-mapped field ingress and egress zones. Its turning radius exceeds 150 feet. It consumes approximately 1 gallon of diesel per acre under full load, and yet in terms of productivity per pass, it delivers cost per acre efficiency unmatched by any standard production model in its class. After completing over 2 decades of primary tillage in Montana and later California, the 747 was restored in 2020 and returned to service. As of its most recent operating status, it is fully functional, privately owned, and actively maintained by its original builders. There is no successor, no equivalent, no second unit. The Big Bud 16 V747 does not represent a design direction or a commercial trend. It is the fixed apex of a particular question. What happens when the field dictates the machine and not the other way around? Some are still running. Others live on in parts, patents, or paint schemes. But all 10 machines define more than just their model years. They define the pace and priorities of the farms that use them. They introduced new systems, altered field behavior, and in some cases, forced an entire industry to redesign around them. Mechanization didn't arrive all at once, and it didn't evolve in a straight line. It came in chassis, engines, and ideas, welded together by necessity, tested under real acres, and measured in seasons, not slogans. What remains isn't nostalgia, it's infrastructure, still visible in the implements we attach, the controls we expect, and the choices still shaped by the machines that pulled before us.